Okay, someone asked about question 6.27, and so in that problem we have three molecules, and it says, are the following molecules chiral or achiral? Well, first of all, for the overall molecule to be chiral, it's going to need to have, first of all, chiral carbons and no mirror plane. No mirror plane of symmetry, because that would make it meso, and since a meso compound is superimposable on its mirror image, it cannot exist in separate handed forms. Okay, so let's take a look at problem 3 first. So if I look at problem 3 here, I'm going to go ahead and add in my groups. So here are the carbons that I can eliminate. First of all, I got to look for chiral carbons. Well, what cannot be a chiral carbon? Okay. Carbons that are not chiral include CH2, CH3s, non-sp3 carbons. So if we look in this molecule, the non-sp3 carbons eliminates all the carbons in the ring. It eliminates the CH3s. The only thing that's left is this CH, but does that CH have two of the same groups attached to it? It does. And so carbons will not be chiral if they're CH2, CH3s, or have two identical groups attached. Okay, that's what will make a molecule not chiral. So 3 is not chiral, or what we would call achiral. For B, or for 2 here, silicon we're going to treat as if carbon. So does this single silicon have 4 different groups attached to it? Sure. It's got a CH3, an H, an isopropyl group, and a methoxy group. So in this case, that silicon has 4 different groups attached to it. It would be chiral, meaning that it is not superimposable on its mirror image. It can exist in 2 non-superimposable mirror image isomer forms. So it would be chiral. And then finally, number 1, if we look at 1, do we have any chiral centers? We sure do. We have these 2 carbons. Can I pass a mirror? Well, let me go back, and maybe we don't. So if I look at this molecule, do I have 2 chiral centers here? Well, after a discussion today in class, I can pass a mirror plane like that through the molecule, and so those are no longer chiral. So in this case, we have no chiral centers, and therefore that molecule is not chiral. So actually, the only molecule that is chiral is number 2. Okay.